Hi, my name is Zachary Katzman, and I'm a fourth year NPV major working in the Human Performance Lab here at UC Davis. One thing that we're very interested in our lab is running and running related injuries. And a technology that's come about in recent years to assess running related injuries is the wearable device. Wearable devices are devices that we can place on runners as they go for a run, and we can use the information that they provide to hopefully predict and prevent their injuries. One specific type of wearable device that we use is the inertial measurement unit, or IMU. IMUs can measure several different variables, such as accelerations and angular velocities of the landmarks at which they're placed. However, this project just focuses on accelerations. IMU placement isn't always consistent, and movement might occur during use, which could affect the acceleration signals that are produced. However, we don't know the extent of these effects. So the purpose of this project was to systematically vary device placement and then to quantify the root mean square error, or RMSE, across a single stride per trial, as well as the changes in peak magnitude and the timing of those peaks caused by misplacement. So the methods that we used to accomplish this were to have 30 runners run 25-meter trials. And we had a pair of IMUs. One was placed correctly at either the distal tibia, the iliac crest, or the sacrum, and one was misplaced either to the upper right or to the upper left by 5 centimeters. Then we filtered the data and rotated it to an anatomical reference frame. We then isolated a single stride from the middle of each trial and determined the root mean square error between the correct and misplaced IMUs, as well as the difference in peak magnitude and the timing of those acceleration peaks. We then tested for statistical significance using paired t-tests. So here's some of the data that was produced, and I'll use the distal tibia data as an example. So this figure has 3 parts to it. On the left, we see the average values across a stride, with the correct values shown in black and their standard deviations shown in gray. Then we have the upper right misplaced IMU shown in red, and the upper left misplaced IMU shown in blue. And as you can see, the values follow the same general pattern across a stride. However, there are some slight variations in magnitude and timing. So we quantified the average difference across a stride using RMSE, and those values are shown here. And we use the unit of a G, which is equal to 9.8 meters per second squared, or gravity. And as you can see, the differences are most pronounced at peaks. So that's what we look at on the right here. On the x-axis, you can see that the upper right IMUs are shown in red, and the upper left IMUs are shown in blue. The correct value is represented by this dotted line at 0, and positive values mean that the correct value was greater than the misplaced one. Negative values mean that the correct value was less than the misplaced one. And as you can see, there's a pretty large distribution around the correct value for both magnitude and for timing. So in 4 of 6 cases, there were significant differences in magnitude, and in 5 of 6 cases, there were significant differences in timing. So this was just the data for the resultant vector, but when we looked at individual axes, we found that 94% of them showed significant differences in magnitude, and 83% of them showed significant differences in timing. So based on these results, investigators should carefully consider their desired outcomes and keep in mind that misplacement may cause error of between 0.2 and 0.7 G across a stride, with this difference being as high as 0.85 G at peaks. And this is a pretty large percentage of the total values that we measured, which could make it clinically significant. So to minimize errors in acceleration, magnitude, and timing, users should be trained in correct placement of devices before using them, and they should use technology such as belts that minimize device movement during use, which would ensure consistent placement. If you have any questions, please feel free to use the conference's Q&A platform or to contact us at the links shown here. Thank you.